Hello and welcome to this tutorial. In this tutorial I'll show you how to create a free CAD assembly similar to the one or exactly the same as the one shown on the screen. If we look on the left hand side, this assembly is named the crank assembly. It consists of the crank and the flywheel, which we've created in previous practicums, and then there are a few bought out items. There's this parallel pin, 6mm, M6 tolerance, 100mm long. There's another parallel pin, also, 3mm diameter, M6 tolerance, 26mm long. That's this one over here. And then there are two hex head set screws, M4, 6mm long. So the flywheel is shown in transparent mode so that you can actually see the M4x6 set screws that are in position. Alright, so that's what we're going to create. Let's start. So if you enter bozart.com, you go to the home page, then you click on products, you click on standard fastening elements, and then you are at this window here. So we click on pins. We are interested in dowel pins. Okay, and if you scroll down, the specific pin with the M6 tolerance is this one over here. Okay, if you click on this pin over here, I can show you the tolerance is shown as H6. Alright, so that's not the pin we want. We want this pin over here with a tolerance of M6. Okay, so you scroll down, you you can enter the diameter and the length here, but it's not necessary. You can go directly to CAD download. Okay, and then scroll down, and over here you need to enter the diameter. Let's download the 3mm by 26 dowel pin. There you can once again see the tolerance as M6. Okay, and then we say generate CAD. It will then ask you to log in. Okay, so I'm quickly going to log in here. Okay, so I've logged in, and then you need to select the format of CAD download. If you haven't done so already, you should select the step format, and then you can say generate CAD. Okay, and there it's being generated. It's a parallel pin, 3mm diameter, M6 tolerance by 26 long. Okay, and the other pin that we want to download is a 6mm diameter and also M6 tolerance, and the length of this pin, if we scroll down, is 100mm. Okay, so we can say generate CAD, and there we go. It's 6mm diameter, M6 tolerance, 100mm long. Right, so what we do then is we say download all files. Okay, I think it's been downloaded twice actually. So if we go to downloads, I think it's this one over here actually. If we extract that, there you go. Now it's in subfolders. Okay, so be that as it may, there's the step file, the step files that we are interested in. Okay, so I'm just going to select the step files and move it to the desktop. Let's do that. Move here, take that one, desktop, move here. Okay. And I'll clean up my downloads. Okay, so if we go to desktop now, okay, so there we go. There's the crank and the flywheel that you also have available on ClickUp. It's the memorandum crank and flywheel, and there are the two step files. So what you can do also is just rename, because downloading the step file from the Bozard website, it gives you the Bozard part number as well as the description of the part. Okay, but if you want to, it's good practice, and I recommend that we copy this DIN number and the ISO number into the file name as well. Okay, so you can highlight that, copy, and rename that. Go to the start, say paste. Okay, so that's the DIN number. Let's copy it's approximately, that's why that tilde is there, approximately the same as the ISO tolerance. So I guess the DIN number is sufficient. You don't need to copy the ISO number as well. The DIN number is sufficient. Okay, so let's leave it at that. I just want to do the same for this file name, so we will rename it. Go to the start, say paste DIN, and we can put in a dash. Let's do the same here. Okay. Right, so with that done, now we go back to FreeCAD, and this is where we start a new document. What I'm going to do is I'm going to close my FreeCAD and open a new. I'm going to close all these files, otherwise I think it can get quite confusing. So let's just close everything. We are going to, right, so this is the new file we opened. There's nothing else open here, so we can say file, import. I don't know why it doesn't want to do that. Okay, file, no, it doesn't want to. Let's save this file, save as. So we go to the desktop and we say, cancel. Let's cancel that. Close the document. Okay, so now we open a new document. It's active. That was the problem with the previous document. It wasn't active. Okay, so now we can say file, import, and we can go to desktop, and let's import. Yeah, we can do the top one, open it. Right, with that import done, we select the imported step file in the model tree, and we go to Part Design Workbench, and we click create a body and make it active. It's important this must be selected, and then you press create a body inside the Part Design Workbench. Okay. Now you will see this is not highlighted anymore, and we've created a body, and there's a base feature in the body. Okay, so what we do next is, this is just a recommendation, it's not compulsory, but what I recommend you do, take the copy the step file name, and we name it. We go to FreeCAD, you right click, rename, and paste that step file name, okay, in the body. Then we know that's the body, alright. We can also then file, save as, and paste the name in here, right. So and then the last thing we do, with the body selected, you right click and select random color. Okay, just so that everything is not gray and dull. Right, and then file, save it again. Okay, so that's done. Now we repeat that process for the second pin. So let's just go through it. So in the part design workbench, we create a new empty document. That document is active. It's bold face, as you can see. So now we can say file, import, and then we select the bottom one, open. Right, with the this is the imported step file. With that selected, in the part design workbench, we click create a new body, and now we do exactly what we did before. I want to rename the body, so I can go there, copy that, go back to FreeCAD, rename the body, and paste that. Okay, and then file, save as, and we paste it here as well, save. Right, so there we have our, okay, last thing, we obviously will also want to change the color. Select a random color, and that looks good. Okay, right, so with that done, now the next step is to start creating our assembly. Sorry, before I do that, you have to download and install 2 additional workbenches. Okay, so you need to go to Tools, Add-on Manager, and install Assembly 4. It's already installed on my computer. And then the other workbench is Fasteners. You also have to install that. Alright, so those 2 you have to install. Let me show you again. It's under Tools, Add-on Manager, Assembly 4. This is alphabetically sorted, so Assembly 4 and Fasteners you have to install. Okay, so now what I'm going to do is I'm going to open the Fastener Workbench. So I click on this drop down menu and I go to Fastener Workbench. There we go. Right, and what we want is an M4 by 6 set screw, and I know that it is this hexagon socket set screw with a flat point. Okay, that's the one I want. So you can create a new document and click on this icon. Then the default is an M6 by 6 screw. Okay, if you select it in the model tree, you can go down, click here and select M4. The length is already correct. Okay, so that's what we want. So the white tick in the blue circle, we need to recompute. So there we go. So alright, so now let's just see. There is the set screw. But what I recommend you do is in Bozart, if we go back, we want to see what material and what length, and is this set screw actually available. Okay, so if we just go back, not dowel pins, we go back one more and one more, screws, set screws. Okay, we are interested in alright, so we can, if we are interested in stainless steel set screws, so we can go to material and select stainless steel, and there you go. Here we see a hex socket set screw with flat point. A2 is more common than A4 in my experience. Okay, and A2 is absolutely sufficient. So if we click there, now we go down to the diameter. We're looking for M4. We're looking for a 6 millimeter length, and there you can see it is indeed available in stainless steel M4 by 6. You can open it here, and there are the length and the dimensions of the set screw. Alright, so we are all good. What we do want to know, here we go. So we just want to make sure what is the ISO and DIN numbers. And in this case, it's not there's no tilde before the ISO, so we can simply copy that ISO number, go to FreeCAD, and well, yeah, let's do that. Okay, let's say file, save as. We can paste ISO. If you like, you can also add the DIN number. Copy that, go to FreeCAD, paste that, and then you can even hex socket set screw with flat point. You can even copy that. This is a recommendation, and it makes it easy if you then end up buying this fastener. The ISO, the DIN number is there, the description is as per it's correct. Someone will find this item easily. Your buyer will easily find it, or if you have to search for it, you go to a fastener supply shop, you will find it quite easily. Alright, the only other thing that we want, okay, it's not shown here. We just add M4 by 6. Alright, and then we can say save. Okay, so this is now in the Fastener Workbench. What we want to do is go back to the Part Design Workbench. In the model tree, with this selected, we click on Create a Body, and what we can do is File, Save As. We can copy that, go to the cancel, let's just cancel that, we go to the body, we say rename, and we say paste, and then we can just delete the FreeCAD file name. There we go. Alright, and with that done, what we can now do once again is select the body, right click and assign a random color. If you don't like the color, you can just go there again and say random color once again, and then the color is different. Alright. Okay, I think I want to change the color once again. There we go. Alright, so we're happy with that, and we can save this file. Right, so now we have all our bought out items, and if you like, you can let's do that. On the desktop, you can neaten up your files. So let's do that. Let's close FreeCAD quickly. You can save that. Alright, so we don't need the step file anymore. We don't need this step file. Alright, and we can create a new folder, and we can call this folder bought outs. Okay, and this is once again just a recommendation. So then you can select each of these bought out items and put it in the bought out folder. Alright, so we'll have to open FreeCAD once again. Okay, so let's open the files we've just created. We'll say open in the desktop, board outs, we click open, file, open, second one, file, open, last one. Right, so there are our 3 files, so let's open the other 2 files as well. A crank, and file, open, the flywheel. Right. Okay, currently the flywheel is the active document. It's boldface over here. So what we now do is we go to Part Design Assembly 4 Workbench. Okay, and if it's not installed on your computer, what you do is you go to Tools, Add-on Manager, Assembly 4. And as you can see, it's already installed on my machine. But you will click it. It will download the information and install update. Already up to date. Okay, so we don't have to worry about that. Cancel. So that's the procedure you will follow to install Assembly 4. In Assembly 4, with the flywheel selected, we go to this icon over here. Okay. Now sometimes, and I don't know why this is the case, but sometimes everything is grayed out. If that is the case, alright, let's just open the flywheel, double click, select the body. You need to play around with this. It's now in the Part Design Workbench. I've double clicked on the body. That's why I jumped to the Part Design Workbench. Go back to Assembly 4, click this icon again. And now it's not grayed out. Now we can actually add a new coordinate system, which is what we want to do. Alright, so the coordinate system, you can name it. Okay, so what I recommend for this practicum, we call this LCS 6mm hole. LCS stands for Local Coordinate System. Okay, we say OK. Right, now this window opens and selecting is active. Okay, so you select this one of the either this side or the other side. You select the diameter. Okay, and now you've selected that edge. But now you have to say what is the attachment mode. And you will notice concentric is bold. Okay, it recommends concentric, and that's what I also recommend. So click on concentric. Then the message here at the top says it's attached with mode concentric, and you can say OK. Okay. Now we need 2 more coordinate systems. Okay, and you will notice that we need to recompute the body. Okay, but we need 2 more because we are going to insert those M4x6 grub screws or set screws. Okay, so for that, without going into the detail, okay, if you look at this view over here, that view, alright. So the depth of the clearance hole at the top is set by the top line over here. That's the depth, alright, not the bottom line, the top line. Okay, so what we want to do is we want to create a local coordinate system that's concentric with that circle over there. Right, so let's do that quickly. With the body selected, click this icon. You see now it's grayed out again. I really don't know why it does that. Okay, it goes into the part design workbench. Go back to assembly 4. Let's see if now it wants to do it. Okay, so this we call M4 hole 1. Okay, we make sure we select the top, the big diameter or circumference. Alright, and we go to concentric and we say okay. Alright, we need to recompute. Now we orientate our part so that this circle is now visible. In the assembly 4, you see it's grayed out again. Alright. Model, go back to assembly 4. Okay, we say now it's active. So we say LCS M4 hole 2. Okay, we select that circle or diameter and we say concentric and we say okay. Right, so our LCSs are now created and we're happy with that. So we can now file, save as, and you can save this flywheel with a different name if you like. It's not compulsory, but let's do that. Alright, so let's say save. And there we go. That's fine. It's done. So next one. So now we double click on the crank. And we do exactly the same. We're going to create 2 local coordinate systems. One on this side and one on the opposite side. Alright, so let's do that quickly. So with the, I think I know why. I think you have to go to, now the body is highlighted. Let's see if that works. Okay, so I went down to body crank and I selected the pocket, the last feature, and now everything is highlighted. Let's see if that works. No, it doesn't work. Body crank. You see, body crank must also be active. Right, now I think it will work. Let's just see. Assembly 4. So it's a little bit trial and error. Still not. Why would that be? There we go. Now it's active. So just click and unclick until you can actually select a new coordinate system. Alright, so this coordinate system we'll call LCS 6mm hole. Okay, and we say that circle and we say concentric and we say okay. Alright, we need to recompute. The body crank selected. Now we say once again, yes, there it's happy. New coordinate system, LCS 3mm hole. Okay, we click the small diameter hole and we say concentric and we say okay. Alright, and we recompute. Okay, that's what we need to do here. Go to crank. We say file, save as, and we're going to rename it to 0406. Alright. Okay, and now all we need to do now is allocate local coordinate systems to these parts as well. So we select the body, click new coordinate system, LCS 1 is fine, and what we want to do is select this bottom circle, concentric, say OK. That's fine, so we can save that. Okay, and then double click on the next one, select the body, click this icon, say new coordinate system, LCS 1 is fine, and what I recommend is take this roundish edge, not that edge, doesn't matter really, but you will see in a minute that this is actually a bit neater. So we say concentric, we say OK, recompute, file, save, okay, and then double click that one, select the body, click this icon, new coordinate system, that's fine. Alright, and what we want is this roundish edge, click that, click concentric, apply, okay. We recompute that and we say file, save. Alright, so with that done, we are now ready to create the assembly of these 5 parts. Okay, so in the assembly for Workbench, we click create a new empty document, and that document is now active. All these files must be open. That document, the new document, is active, and we click this icon, create a new assembly container. Right, now we say file, save as, and my recommendation again is for the assemblies to, I want to name them caps lock, obviously, crank, ASCII, and we say 220406. Right, so let's save that, and you need to close each of these documents. Okay, close the document, I'll show you in a minute. Close each document, the crank assembly is still open, and then you say once again file, open. Right, so we go to the board layouts, we open. If we now go to crank assembly, double click that, click this icon, you can see that the file name is as we have saved it. There's nothing in front here. It says body of something like that. There's no, it's straight the name of the file. That's what you want. Okay, you want this name and that name to be exactly the same. Okay, we're not going to insert it now, we'll do that in a minute. Alright, let's open the next one and I'll show you. If you do that, go to the crank assembly, just test it. There you can see again the name is as per the name that we've given it here. Okay, it's exactly the same. The file name appears here in the part to be inserted name. We're not going to insert it, I'm just showing you what it's supposed to look like. Okay, so file, open, ISO, right. Crank assembly, I can show you. Same. It's once again, the name is exactly the same as the name that appears here. Okay, we're not going to insert it. File, open. Right, we don't want the board outs, we want the crank. Okay, we test in the crank assembly. Okay, it's not active. Crank assembly. Crank is there. Right. Cancel. the name is the same. Alright, so let me show you once more. Open, it's the flywheel, open. Okay, so if we go to crank assembly, click on the assembly, the flywheel name is there. That's the name of the file, and the body flywheel is also there. Alright, so that's exactly what you want. If yours doesn't look like this, then what you need to do is you need to click on each of these files, close it, and open it again. And then check. Once you've opened it, that's how it works. Then the name will be correct. Alright. So, now we're ready to start the assembly. So we make sure our crank assembly is active. And let's cancel this. Right, so you can highlight the assembly part of this file, okay, and you say insert a link to a part, okay, and now we start with the crank. Click the crank, we say open file, cancel, sorry, not open file, insert. We click insert, and there we go. Now the crank is in the 3D view. Alright, what you now have to do is you need to select which local coordinate system is aligned with which local coordinate system. So we select the local coordinate system 6mm hole, attached to the parent assembly, the local coordinate system origin, and we say OK. And there our first part is now installed or inserted in the assembly. Okay, now we do the rest. With the assembly highlighted, click this icon. Now we want to insert this 6 by 100 dowel pin. Okay, that one over there. We say not open file, we say insert. Okay, now you can see the local coordinate system of that pin is selected by default. How do we want to attach it? We want to attach it to body crank, the local coordinate system 6mm hole. And with that done, we just say OK. And now we are ready. There you go. Our assembly is taking shape. So with the assembly highlighted, we say insert a link to a part. Now we want to take this 3mm by 26 dowel pin. We say insert. The local coordinate system, yes, is by default selected. How do we want to select it or attach it? To the body crank, the LCS 3mm hole. And now you can see there's a problem. Okay, this is not the way the assembly should look. We have to now rotate the inserted part. Okay, and what you need to do is just have a look here at the coordinate systems. You can see if we rotate it, we can rotate it either about the red axis or the green axis. Okay, and the red is X and green is Y. Okay, so let's rotate it about Y, and we click plus 90 degrees once, and we click it again, and there you go. Now it's correctly orientated. Okay, so the last body we want to import is the flywheel. We insert that. We select the local coordinate system 6mm hole of the flywheel, and we want to attach that to the body crank 6mm hole. Alright, so it updates automatically in the 3D view. We now want to adjust it, and if you are not sure in which direction, you can play with these arrows. You can see that that's not right, it's not X, it's also not Y. Okay, so it is the Z direction. So the only question is it positive Z? No, it's in the negative Z direction. Okay, so now we need to calculate the distance that we want to position the flywheel, we will obviously need the thickness of the crankshaft as well as the thickness of the flywheel plus the gap between the two. Alright, so in order to do that, I'm just going to quickly open a spreadsheet. Okay, so I know the thickness of the crank is 15 millimeters, the same for the flywheel, and I know that the gap between the two is supposed to be 19.9, so I can easily just sum these three cells. Okay, so it's 49.9 millimeters. Right, let's see if that works. So if we say, so it will be minus 49.9. I think it wants a comma 9. Let's just see. Sorry, I just want to see. Not 4.9. Minus 49.9. There we go. Right, so with that done, we can okay that. Okay, so what the last bought out item that we need to insert is then the two is the grub screw, and that's inserted in two locations. Right, so what we do is select the assembly, import, select the hexagon socket set screw, say insert. We use the local coordinate system 1 of the set screw. We attach it to the flywheel, local coordinate system M4 hole 1. But now we must just be careful, okay, because I'm not sure if it's visible here, but this set screw is actually the wrong way around. So we need to rotate it either about the x-axis or the y-axis, the red or the green. And if you look here at the top right, red is x, green is y. So we need to rotate it either about x. Okay, let's do that. And now you can see the orientation of that set screw is correct. But now we need to offset it in the z direction. Okay, and now we again need to calculate the exact distance. Alright, so the diameter of the flywheel is 49 millimeters. So if we divide that by 2, we get 24.5. The depth of this hole is 15.5 millimeters. 15. Okay, so we say 15, and we can subtract the 15 from that. So that's 9.5 is the distance from the center to that face over there. The thickness of this or the diameter of this shaft is 6 millimeters. So we can say equals 6 divided by 2. 2. So we can say 9.5 minus 3 is 6.5. Okay. So in other words, that's the distance we want to offset the set screw is 6.5, not point. 6, so let's just try again. 6.5. There we go. All right. So if we look now, I think it's this. No. Yes, there we go. So now you can clearly see the set screw is at exactly the right location. So it is 6.5 millimeters below the local coordinate system. That's what we want. Okay, that's exactly what we want. Alright, so now it's simply a matter of inserting yet another set screw. We insert it. we choose the local coordinate system 1 of the set screw, and we attach it to the body flywheel local coordinate system M4 hole 2. Okay, there you can see it's correctly orientated. Okay, but we need to offset it in the negative Z direction. Yes, minus 6.6,5. Minus 6,5. There we go. Perfect. Right, so that's as easy as that. What we can do now, just to neaten things up, is you obviously have to save your file. Okay, the last thing we can do just to neaten things up is we can hide all these origins. If we go to body crank, not the origins, the local coordinate systems rather. So you just need to go down the model tree, select the local coordinate system and press space. Alright, there we go. And then we can save our file. Okay, so for the last part of this tutorial, I just want to show you what happens if you change in the crank and the flywheel, if you change parameters that we've defined in the spreadsheet. Okay, so if you open the crank inputs, go to window, go to tile. Alright, so if we change the outer diameter, it updates here in this window. We can undo that. Sorry, that was 24. So all of that works. Same for the thickness. If you change that to, for example, 20 millimeters, it updates. You have to go to the crank assembly and just say recompute. Then as you can see, it now adjusted, it shifted to the correct location. Alright, so if we change this back to 15, right, in order to update the locations of all the parts, you have to double click the crank assembly and click recompute, and then it updates. Okay, yeah, and obviously all the other things will also work. It won't make sense really to change, but we can do that. We can change that in center hole diameter. Okay, the same with the offset hole diameter. We can make bigger if you wanted to do that. The important one will be this offset. If we change that to, for example, 6 millimeters, alright, and we double click crankshaft, and there we go. It updates it automatically. Alright, which is exactly what we want. I'm just changing it back to 8 millimeters. Right, so let me show you if we do the same for the flywheel, what happens there. The way we've defined the local coordinate systems, there's only one aspect of this assembly that won't update accordingly, and that's the set screw will then be at the incorrect location. Okay, this set screw is set to the local coordinate system that's fixed to the bottom of this recess hole. Alright, so let me show you what I mean. If we open the that's not what I wanted to do. Let's just go to flywheel inputs. Windows style. Let's see if this works. Yes, it works. Right. So outer diameter, inner diameter, thickness, all of that will work. The access hole will work. the one that will give a problem if we make this 10 millimeters, for example. Okay, there you can see it's updated, but if we recompute, then the set screw is in the wrong location. So you will have to go back into the assembly. If this is a change that you will have made, you will have to go back into the assembly. And yeah, update the location of the set screw. Right, you can update that. Or what you could also do, if this doesn't make sense to you, because this is quite tricky, what you can also do is delete the hex screw and insert a new one. Right. So what I mean, for our purposes, we know it's 15, and we go back to the crank assembly and we say recompute, and there we go. Okay, so what do you then submit as submission for this practicum? You can actually delete the original crank and flywheel. Just make sure you delete the right files, and then what you should have is all the bought out items, the 3 bought out items, and the crank assy and flywheel, all these files. Right, so what you can do is select all of them. Okay, you select them, and then on my computer I say compress here as a zip. Okay, and then that's the zip file. I can rename it to whatever you want to call it. Prac 4. Let's do this. 220406. Prac 4 memo. Right, and there we go. That's what you. This is what you submit. So it should be around 300 kilobits, a small file. All right. Thank you for watching.